Okay, hi everyone. So I'll be doing this assignment. This is computer architecture. I've got like 11 questions. One of them is already done now. So the first one was like write a program in assembly language to subtract two 16-bit numbers without using the subtracting instruction. Pretty easy. Just take like a two's complement by complementing and then adding one and the usual stuff. The second one is write an assembly program to find the average of 15 numbers, not 16, not 8, 15, stored in the consecutive locations in a memory. Alright, so 15 is something like 8 plus, so it's 7, sure, so just 1, 1, 1, something like that. 1, 1, 1, 1, base 2, right? Yes. So we want to divide by some 4-bit number. That's the thing. So the usual algorithm for doing that, I'm just going to try to do that first. So I have my directory where I'm storing all the code. So I'm just going to make a sort of a Python file or something like a how do I say this? Okay, this isn't how I kind of want to be doing this. Okay, notes plus right. So let's just say div dot ipynb. So I'm making a Jupyter notebook. I know, probably not a very nice way to be doing this, but whatever. So the function we want to be doing is something like so it takes into arrays. So what I'm thinking of is that these are like strings, or let's just actually use binary arrays, right? So true false, or 1 zeros. That's probably the thing. So let's just like take some examples. So we are going to be having something like 16-bit arrays. So let's just say the divisor, that's probably not a way to be doing it. So let's call it A and B. So B is the divisor, A is the dividend. So it's 16-bit number, so whatever, it's like not 16-bit, it's like some 32-bit number, right? So it's something like 106. I have no idea actually, so how do I go ahead? So it's just 1, right? So sure, so like let's just say 101, this to the, so this is 3, so it's like 5, that's 15 numbers plus I don't know, just put 0 over there or something like that. Sure, so B will be, so it's just 0 and how many, so 4 are already used because of the 111, so this would be just B12 and that, and then just dot 14, right? So first we need a function to like convert it to integers. So to int of a sequence, what that does is so it's some length sequence and it's the length of it. This is going to be like a big endian, so basically the zeroth thing will be storing, actually yeah, that's how we want it to be happening, right? The zeroth will be storing the larger values. So this should actually be reversed. Right, I'll give you the rationale behind it. So basically the thing is that the zeroth place is having the most significant bit. Wait a second, if that is the case, then this shouldn't be the thing, because this is the least significant bit we should have thinking of. Okay, so this is right, this should be 12. Okay, so the zeroth bit is the most significant bit and is the length of this thing. So what we'll go ahead with is so 2 power 0 will be the least significant bit, so basically n minus 1. So for I in the range n, so since there are n of these, n minus 1 is what we'll use. So sequence n minus 1, whatever is that number, so we will just make s equal to 0, s plus equal to that times, obviously, so if this is there or if not there, so it's 0 or 1, that times whatever is the radix, so the place value thing, so it's just 2 power I. Yeah, that's the thing, and then we just return s. So just to see how this is going on, so just do integer of what a, not a, actually let's go for b and just run this. Yes, Python whatever. So not interested in, so it's not what we want. That's not good. Something didn't go quite correct, isn't that right? 16-bit number. N minus 1, oh okay, it's not supposed to be n minus 1, it's n minus 5. index out of range. So it's n minus 1, and subtract with that is just sequence 1. It starts with 0. Okay, it's supposed to n minus 1 minus I. Sorry for that. 15 as expected. Okay, so we have a function which converts to sequences, whatever. What we want is some way to be multiplying these things. So the way this works in Mips is that you have these in two registers, right? That's easy to do. Then once these are in the registers, we want to shift them. So basically your divisor is somewhere, whatever. Yeah, you shift your dividend. So let's think about it. C will just be like some empty thing, so 0 times the length of A, right? So A is our dividend basically. So what we'll do is we'll start siphoning numbers from A into C, right? Yeah, so first we just need a for loop. So for I in range, so the number of numbers that we have, so 16 over here. And actually let's not use 16, let's go for 32 or something. So this is like 3 times, so you just need 30, so it's something like 10, and this would just be 0 0, and so this would be 32 is like, so it's just 28. Yes, it's still gonna give us the same thing, I'm sure of that. Okay, but now yeah, this is a different scenario altogether. Actually let's make it 0 1 0 just for the sake of 0 1 1, whatever. Sure, or you know, we could just make this like 0 to the power of, I have no idea what I'm doing, but maybe 27, and then over here we can just put like 1 to the 4, because so that would be 2 power 5 minus 1. This is 2 power 4 minus 1. Yes, so 2 power 4 minus 1 does divide 2 power 5 minus 1, right? I hope so. Does it? No, it doesn't. It doesn't. Make it 8. 8 is better. So 13 minus 6 is like 24. What? No. Yeah, sorry. Okay, what's going on in my head? So AB we got it. S is just this stuff. So to be sure, then C is, so we'll also do int A. It's supposed to be 2 power 8 minus 1. 2 power 8 is like 16, so 256 minus 1, so 255, and which is just a multiple of 15. Sure. Is it? I mean, it's like 51 divided by 3. Yes, it is. Okay, so C is this. So for I in range, whatever is the length of this thing, which is 32. We know the length of A is 32, so just 32 from there. What we'll do is we'll siphon stuff from A into C. So we'll do a left shift, so I need to have that operation. So we'll be like define left shift logical on a sequence. So let's just put like, actually we'll just put sequence over there. Yes, I suppose this makes sense. Yeah, I think so. So what we will do is just like shift everything, and then, so yeah, sure. So for I in range, the length of the sequence minus 1, right? What we'll do is the sequence I thing, that will just be equal to sequence I plus 1. Sure. And then finally sequence last one, make it 0, right? So that just pretty much just multiplies by 2. Okay, so what we'll do is for I in range 32, we'll left shift. So first we'll check whatever is the first bit of this guy of A. So we need this to be some sort of a, what do we call it, unsigned number, otherwise it doesn't really make sense. So we're doing logical shifts, we're checking if it's signed or unsigned. Hey, so if the first bit is 1, what happens is that it's negative essentially, right? So if A0 is equal to 1, that is to say, like whatever is the binary so signed binary format for a, if that thing is negative, so if a is less than 0, right? So what we'll do is yeah, right, this is making sense. So we'll left shift logical C, right? Then we'll set the least significant bit of C to be equal to 1, right? So that's basically like adding 1 essentially. So this is sort of like add 1 to C, right? Yeah, and then what? And we'll also like obviously left shift A, but let it be for the other time. If it doesn't happen, we just left shift C, right? So that's like a common operation, so we'll just do this thing. If this is not equal to 1, it's equal to 0, then whatever, we don't care. And then we will left shift A, right? Okay, we have to store this divisor thing, this A thing, in some place, I suppose. It's just 32, right? Yeah, it's just 32. It's just the first one, then the second one, and so on. So okay, this shouldn't really matter. This shouldn't matter. Yeah, the first time it exceeds it, it just cancels it in any case. And because of the way the binary format works, it's a very simple algorithm. So left shift logical A, then if so, we'll also have this thing called a divisor. I have no idea what I'm doing. Right. So how do I perform subtraction now? So I'll have to have some sort of a sub command. Oh, this is going to be harsh. So sequence, what I'll do is convert it to integer. So to integer, then so we have a sequence, and so divisor, and then the dividend. So we'll convert the divisor to something, to basically like x, I don't know. We'll say y is equal to integer dividend. Now if x is bigger than y, or in the Mips terminology, it's something like less than, right? So if set is less than, that's what we use. So if y is less than x, and what we'll just do is like subtract. So we set x to be equal to x minus y, right? And then we have to convert this y thing to a string, right? So we also need to write that. So define to list for a number n. What we'll do is like, so 32-bit number, right? Yeah, how do I do this thing? So for just make a list. So L is just 0, 32. Now for I in range 32, so 32 iteration. So 0th iteration is like, so if n remainder to power I, or I can just do n remainder 2. In that case, L 32 minus I suppose, which is 31 minus I. This will just be equal to 1, otherwise don't do anything. Right. And we obviously have to do n equal to n by 2. Yes. Gets 32-bit 32 numbers. Shouldn't be hard. So here we are assuming a and b are positive. For negatives, we really don't want to be dealing with that right now. Just assume it's positive numbers. Okay, so that's okay. To list, to int, left shift logical subtraction. We really should check all of these first. Okay, so we'll just have something like so a is this, so to list, let's just say 16, I just want to print that for now. Bro, what? It didn't return me anything. Oh, because I'm not returning anything at all. Okay, so it's returning right 10000. Sure, makes sense. That's 2 power 4. So okay, to list of 16 is okay. What about 15? Yes, as expected. To list of this and then to int of this. Is that equal to x, where this thing is x? So like for x in range, I don't know, I'm just gonna take some random number, so like let's say 100. If not, then print boo break. Okay, just gonna do that. No boos. So that means this is actually working. Sure. So these two are okay. Left shift is most likely okay. I don't think there can be anything problematic with that. The subtraction thing is also most likely okay. Right, you just do x to that. Now we just return to list x. Here we are kind of assuming that x has to be greater than y, because if it's not, then it's messed up. But yeah, over here as well, actually it's not like just equal to, it's more like, where did that go? Right, what was I doing? Okay, you logical shift A and you logical shift C. Now we also have to store the divisor somewhere, right? So we'll just call it as D. So D is the same thing as A, so we'll just say A dot copy. That's the actual value of the divisor. In A, your divisor thing is like moving, basically. So if to int, I know this is really problematic, but I don't have any other choice to it. So if this is less than to int A, right? So actually let's put that in some sort of a container. So let's just call it x, or something like t for temporary variables. But yeah, so if this is true, then we set t to 1, right? So set t to 1 if whatever. Okay, true, right? So if A happens to be bigger than C, sorry, yeah, right, A is just the divisor, so I should probably using T over there. So if the divisor happens to be greater, we don't do anything. If it's less than or equal to, then we subtract it out, right? So if not T, right? So if T is equal to 0, or I should in this context to say if T is false. I am writing it like that for in a purposeful manner. I'm not writing it simply. You'll get why that is the case. So if T is false, that is if T is not equal, so if T is equal to 0, right, in that case what we want to do is, what did we want to do, right? In that case, what we are saying is like that D is less than or equal to C. In that case, we can subtract it out. So we'll just say C is equal to C minus D. So to list of to int C minus to int D. Yes, and that might just be zeros or whatever, we don't care, and this keeps on going. Yes. Also, we probably have to set the what do we call it, the quotient, right? We just have a q thing, so q is once again just 0 power 32. Okay. Right, so what we'll just say is like q of I, or whatever is the proper index. We should really just be saying q of minus 1, that's equal to 1. Else well q of minus 1 is just 0. Okay. Okay. Am I making any sense right now? That's a very good question to ask. We should have exactly 32 bits, isn't that right? The last division, everything will be there. So every time you subtract, you should add a 1. Oh, so you shouldn't just left shift A. A contains your what, the dividend, right? Okay, so when you're left shifting that, you're also shifting the quotient at the same time. So left shift the quotient as well. Right, so all of these left shifts happen at the same time. Okay, sure. This one we have to use before shifting A. Okay, this is fine, this is okay. Right, and so this should pretty much give us the value for Q, right? Let's try it out. So we'll, right, so B is in there, isn't it? Sure. So you want to divide this by B. So D won't be A dot copy, would it be? No, A is the divisor. No, it is a dividend. So you are putting stuff from the dividend into C. You have to do B dot copy or just B itself. In fact, let's just call this thing as D. So this thing is a divisor. Okay. And the remainder will now be in C. Yes. So should we just call it R? I suppose yes. Like once everything is done, whatever is left in R is our remainder. Okay, this is okay. This should be R. I think it's okay. Right, so R is purposefully left to be less than D, because it can't be bigger than that. Okay, that sure makes sense. So we'll just print the value of everything basically. So print to int what? To int A also. So A is just the dividend. The to int thing for the divisor, so it's just D, right? And over here what we'll do is just print I have full faith this will not work out, but let's just give it a try. Yep, Q did not work out as expected. Still though, left shift logical. Let's try printing it inside. Range 32, huh? Yeah, it's all 0, 0, 0. Sure. What should we do? I don't think there's another way. We just have to print everything. So we have to print Q and R just to see what's going on. So it's these kind of numbers, which, yeah, I mean they are 0 all the time. Let's also print rather than printing this, let's print A and see what's happening. A should just be getting shifted, that's all. So it's this thing, then it gets left shifted, left shifted, left shifted, so on. Sure. So that's completely fine. Not a big deal with that. Let's print what's happening to C. C or oh, okay. I see what's going wrong. It should be R. So now let's just print what's happening to R throughout. So it's just 0. Not very cool. Hmm. Come on. What's happening to D exactly? I don't think much is happening to D. Yeah, it's just this all the time. Um, what the hell? I don't get it. Okay, let's just first print this stuff. Oh, wait a sec. Okay, I see. I've used C everywhere, that's why. Okay, this should really just help. I see. So that's D, not changing. What about R? Oh, wait. Could it be? I know this is taking much more time than expected, but trust me, this will be really useful because we want to convert this algorithm into assembly, right? So it's 17 comma 0. 17 times of 15, that's like 16 square minus 1. Yes, that's 255. Amazing. So we have the algorithm to, okay, so you know what? Okay, how did that? Yeah, okay, so we'll just print it over there. So okay, we have the algorithm. Now convert it to a while loop. Okay, so we'll have to set some t2 to be equal to 32, right? Now while t2, so basically when t2 is not equal to 0, so it's not equal to 0, do all of this. At the same time increment, oh sorry, decrement. So that can be arranged, not a big deal. So while t2 is less than or equal, so it's not equal to 0, decrement it, so 32, then 31, so on. The last time it's decremented is like 1, and then it's 0, so it's not. Sure. Right. This should probably work out. So when we want to be doing a logical left shift all the time. I see. So all of these things, to list, to integer, these are not really important. So the subtraction thing isn't probably all that important, is it? Where did we use the sub thing at all? We didn't. We actually didn't. Oh, okay, this whole thing we could just have converted to sub. So this we could have just said it's like sub. And it would have worked. Sure. And just to be sure, let's run this. Yeah, to be expected. What is it printing exactly? Okay, what the dividend is not defined. Divisor dividend. Yes, that's more like it. I don't know why I didn't catch up with it. Fine, so it's working. Wait, what? What do you mean 31 and 30? That doesn't make sense. No, that really just doesn't make sense. So R is what has to be reduced, and this is, oh, we shifted the whole thing apparently. Okay, wait a second. So it's two integer. Let's just call it d1, d2 for now, right? This is just really bad. It should also be less than or equal to. Yes, that's how it should be. Hey, so if I put something else, let's say instead of 255, which was our original A thing, let's just put some other thing, right? Let's put a 7 over here, and then what would happen? And that's like, what do you mean it executed like that? Oh, I made the same thing just before. Obviously it's the same. Why is this code same? So it's 254 and 15, which is like 16 times of 15 and plus 14, which makes sense as well. Sure. So we at least have the algorithm. Okay, let's start coding this in Mips. This is going to be the hard part. I've already done some part of it. Okay. So okay. So basically you have this thing. Actually, let's just make a div dot s thing, so that the division algorithm, right? I have no idea what's going on. Why is it still running? Hey, why is it still? Restart. Dude, this isn't healthy. I mean, kernel detection task running. Okay. Sure. Okay, it's just slow. Yeah, it's just because it's slow. It doesn't have to do anything with it. If I just run it all. B is not defined. Huh, that's very weird. Okay, it's working. Okay, let's just get started. So let's suppose that your values are stored. So your A and D thing, these are stored in your, so in my case it was V0 and it's just going to be 15, so we'll set that. Sure. But yeah, so it's V0 and 15. So A in, so for just the sake of it, I'm going to put this in A0, right? And let's just say that D is in A1, just for the sake of it, right? So we're making a function basically. So the function is called div. Okay. Is div a command? I don't know. Whatever. So we'll just call it capital div so that it doesn't cause any confusion. Okay. So what it will do is first we'll just get these two things. It's A0 and A1, which we already have it. Now what it has to do is first thing, set T2 to 32. So which will do like this. I add immediate. So we'll use just as we used over there, T2, and it will be like $0 and 32. Okay, cool. Next, so while T2 is not 0, so we'll basically just have an end instruction. So let's call it end. It's a label. Sure. So branch on equal. So whenever your $T2 is equal to 0, the branch to end. Okay. code. um, so end at end what we do something and then we just return. So we just jump to address. It's not J, I think it's JA, right? How do you jump to a return address? I think it's JR. Yes, it's JR. The register is just return address. Okay, so that's gonna happen like in the end, when this function is done. So if your T2 thing is 0, you're pretty much done. Like you don't really care. Your quotient will store that in let's say V0, and your remainder will be stored in let's say V1. Okay, so first what we'll have to do is like copy this thing, copy your A. Actually no, let's just so we are also shifting A, unfortunately. That ain't good. That is unexpected. But what do we do now? Okay, now what? So your original A thing we cannot just be using. So we'll have to put it in some other variable. So it's in A0. Let's put it in A2. Okay, A2 is already used by some other argument. Wait, no, it's a function call, and we only have 2 arguments. So it's just, yeah. And moreover, these are arguments. Like we don't really care, right? We can always like duplicate these things. So let's just assume they were meant to be destroyed in any case. So okay, so we'll branch when it's equal to 0. We'll just, okay, it has to be $0. Yes. It doesn't really work like that. You have to feed in the value and then equal. Yeah, sure. Okay. So while this is not happening, what's going to happen is first we'll left shift your remainder. So we'll just left shift logical. I don't think that's how it works. Left logical shift left logical. Oh yeah, shift left logical. So logical shift A, which is in A0. So $A0. I really hope this is going to work, but whatever. I suppose that's how we work, right? For shifting. I kind of have forgotten, but let me just check. The shift statement. Okay, so you have to give a destination register. So that will just be A0 once again. You have to give the source register, and you have to give the amount that you want to shift. So just 1. And okay, so we have shifted our A value over there. We also want to be shifted some other values. So first actually we want to be shifting what your R register, which is in V1. Oh, so you also have to probably first just put it as 0. So or you just use add directly. Why even go through this trouble? So okay, and also for V0. So both of these we were initialized to be 0, right? Okay. The divisor is in A1. We do not mess with that at all. So okay, let me just do this branch of point equal to all that stuff. Okay, shift left V1 0. So V1 1. Okay. So just when, so I also want to shift this thing, the Q thing, which is in V0. Okay, so now since we have shifted our A, so right, since that has happened, what we'll do is, if A is less than 0, so set on less than, and you will have the A register, so $A 0, and we'll also have the 0 register, so 0. So is that the way we use the set less than thing? So the thing that we set is put first and then the other two in order. Let's just call that as t, so we'll be putting t0. Okay. Yeah, so if a is less than 0, so if t is 0 basically, then we do this thing. So if right, how do we do that? So branch on equal to 1, right? So whenever this is 1, our t0, we want to be doing stuff. Otherwise it will be 0. And if it is 0, we don't want to be doing stuff. So branch on not equal to, branch on equal to 0. So if it's 0, we skip the stuff. So branch on equal to t0, 0. In the else thing. This will be like if you know a is less than 0. Right. So it just goes to else. If it doesn't, then what we want, so in that case a is in fact less than 0, right? In that case you want to add 1 to the register r, right? So r is in v1, so we'll just say add immediate $v1 $v1 1, right? So here what we are doing is just r minus 1. So basically r is plus equal to 1, essentially, like incrementing r. Okay. I really hope what I'm doing is correct, but whatever. So far what we have done is incremented r, so add 1 to sure, and yeah, and we also done the left shift for v0, I suppose. Oh shit, okay. So you're supposed to be doing this after that. Sorry. Okay, this actually works out.
How are you dividing?
Some algorithm. Algorithm?
Sum bana.
नहीं.
Repeated sum, multiplication, division by multiplication.
वो बहुत स्लो है. I'm not gonna use that. मैं तो नॉर्मल कर रहा हूँ. क्या बोलते हैं जो एक्चुअल डिवीजन को रहता है.
हाँ.
थोड़ा हार्ड वाला है, बट ट्राई कर रहा हूँ खुद.
मैं बोलता हूँ ना कॉल्स. पिछले साल तक ये भी नहीं लाते था, और एक है लेकिन वो घर में है.
Okay, I see.
3 है टोटल. The issue is, are you recording the session?
Yeah.
Delete this part. Delete this part.
Anyway, just somebody interrupted us. Yeah, so we add 1 to r, then we left shift logical a. Yes. Yeah, we are doing that. We also left shift q, so this is that one. So we're doing q is left shifted by 1. Sure. Then we want to do t equal to so this thing, so set less than. Once again we're going to use this t0 thing, so t0. So what happens is r should be less than d, so r is in v1, this is in d is in a1, right? So this thing is t equal to r less than d. Sure. So if t is false, that is if it's equal to 0, right? Okay, so when it's not equal to 0 we jump. Okay, cool. So this is else 1 basically. So branch on not equal to, whenever your t0, if it's not equal to, so you have to give it some sort of a register, right? Okay, so whenever it's equal to not equal to 0, right, then we jump to end2, sorry, else 2, right? Else 2 will be some label, whatever. So if it is 0, we don't jump. If it is 0, in that case we do this stuff, r equal to subtraction of r and d, so we'll just do sub. R is in v1, so sub v1 comma v1 comma d is in a1, so this thing is r equal to r minus d. Sure. Then what? Then we also have to do this stuff, so q minus 1 equal to 1, so basically increment q by 1, so add immediate. Q is in b0, right? So we're just doing like q plus plus. Sure. In terms of Python it's q plus equal to 1, but whatever. Yeah, okay, else, so else to whatever, what do we want to be doing? So in any case it just goes to this else 2, so it doesn't really do anything. Sure. We should really just call it end1 and end2, not, it's called e1, this is e2. Okay, so now what we want to do is like decrement t, so add immediate. t2 is in what? Well, it's just t2 basically, so t2 comma t2 comma minus 1, that pretty much does it. And yeah, so this should actually work out. I have no idea if this will, but well, we gotta give it a try, don't we? Yes. So this is our div method. And this is our main block. So what we'll do is once again the same stuff. A will be this number. So it was like what? So it will be 15. So we do add immediate. So for div, what we have to do is put a in a0. So add immediate a0 0 and 15. 15 is in, oh that's d. So that's a1. So for a0 it's 254. Add immediate dollar a1 dollar 0 251, right? So we want to be jumping to end in any case, but what we'll instead do is, so we'll jump and link to div, and I assume this is the format, right? Yeah, right. So we just put a label and that's how we do it. And then this will just give us the stuff in v1 v2 and hopefully it will be done, and then we'll just jump straight away to the end thing. Yeah. So okay, before this you probably have to, so let's call this as capital E and D, that's probably the same thing. So final end. So final line. Yeah, that's the thing. Okay, this is looking good. So here we're like setting A to be 254. Why did I set it to be 251? I have no idea, but D has to be 15, not 251. Okay, this is how it should be. Yeah, and in the end what we want is our Q and R, which are V0 and V1. So let's try running this on some simulator, and if this works out well, nice. If it doesn't, we'll try to debug it. So control A, control V. Let's step. Hey, this isn't where I wanted it to run. Okay, first just run this whole thing. It's not supposed to be running at this. What's happening? Why is it? Okay, something weird. Anyway, so it's just Mips. So what I guess we should be doing is just remove all of this. Yeah, that's probably gonna work. Okay, let's try doing it. So step. Why did it start from here? Why did it start? Oh, because I put line 16 over there. So we have to put line 1. Right. This should be the thing. So go. Okay, now let's step. So first it will just add, so it will make it 254. Okay, and it will make it 15. That so far so good. It's going to go to this. Register RA is read only. What? But this is stupid. So I can't use jump and link. What do you mean I can't use that? Why can't I do that? Should be allowed to be doing that, right? Why is it read only? No, this is bad. If I can't do that, then you know what? I'm just gonna jump directly to div. I don't care. Okay. Yes, so I'll jump to div directly. I don't care. Or you know what? Like let's actually scrap all that. Let's just remove all of it. So we do this stuff. Then you have all of this happening. And so this thing, jump register, we won't have this. We also won't have this final thing. Cool. Now let's try to do it. So we're supposed to have start line 1, go there. Actually, let's just control A, control C this thing, because who knows what's going to happen. Go there, step 25, 15. Then this is our div command. So first what it does is add immediately to 0, 32. So it's just 32 now. And this is 0, v1 is 0, sure. v2, okay, it's also at 0. Actually, just run this thing. Where did I even read only? Yes, but oh, okay, that was the previous thing. Okay, sure. So what is the values of v? These are supposed to be in. What exactly is going on? Oh, so when you decrement this, you also have to go back, right? You have to go back to your branching condition, right? So we jump to whatever this thing is. So let's call this thing as loop. So jump to loop. Okay, so now let's go to line 1. Control C. So we'll just step. I really hope this is going to work. A0 changed. That makes sense. That sure has to be a thing. T0 became this stuff. What's happening to T2 is kind of our concern, so it's decrementing 30, so on. So okay, it's still 0. I'm just gonna run this whole thing. Okay, what are the variables? Yes, this works. This actually works. Amazing. Yeah, we don't need anything more. So this is basically my submission. Okay, so this is just a div basically thing. So right. So here I'm just not calling function. And directly executing code. To make simulation easier. Okay, but in the end you're not supposed to do that, right? So once it ends, we have to do a return. So jump return to like our register, whatever is your return address, right? So this has to be there in production code. But I'm excluding it right now. Right, not a big deal. Okay, so at least we have the division algorithm. With this we can complete my second question in the assignment out of the 7 questions I have to complete. But yeah, who knew assembly would be so hard? So A2 is just this stuff. So now what we have to do is, so instead of A0 and yeah, so just have to make these go to the correct thing. So hey, I kind of forgot where did I put stuff. So A, this thing is D. So A is in A0, D in what am I writing? So D in A1. Our Q thing is in B0, and our R thing is in B1. Okay, over here what we want to do is just divide by 15. Yeah, so I'm just gonna copy this whole thing, but before that I have to put some instructions. So we want to put this in A0. What do we want to put in A0? Right, our V0 value, right? Yes, so we set V0 to 0. Yeah, so it's V0 which we are really concerned about. So what we'll do is just make this, or you could probably just be putting this in A0, whatever. So we'll just say add immediate. So A0, and then 1, not 1. In fact, why even do an add immediate? We just do an add, that works. So $0. Okay, this is probably not allowed in the simulator, so I'll just say $0 like this. We have to do the same thing for A1 as well. In this case, yes, it's an add immediate which we have to do. So it's A1 $0, and the number that we want to put in is 15. Okay, and yeah, this is good to go. So we'll just copy this whole thing. Okay, so now v0 holds the average since it's the quotient, which is what we wanted. And yeah, that's pretty much it. v1 we don't care about. Okay, so this is okay, I suppose. I'm just gonna see if this is going to work out by putting this in a simulator. So we'll start at line 1, obviously. uh, so here what I was doing is that I was like you know oops so just to debug, I'm putting like 100 in each of these numbers. So it's an average function that I'm building. So each of these numbers I'm just putting as 100. So what I would expect is like the sum would be 1600 by the end of this main loop, and then when I average this should be 16, so sorry, 1500 because the 15 numbers, 1500 upon 15, which would be 100. So let's just run this thing and hope for the best. And yeah, so our hopes are shattered because this is not going to work. Yeah, yep, it's stuck, isn't it? Oh, it actually, why did it say RA is read only? I didn't do a JAL. What happened exactly? Like, what did it do? Evaluation. Okay, what happened to B? That's quite a bit. That isn't what I expected. Staff, teachers. I have no idea what happened. Okay, A1 was 15, so that part is okay. V0 was V0. So V0 is like stores the value of the 15 numbers by the end of this thing. Just gonna whatever. So first I'm just going to see what happens if I don't have this average function. So we'll start at line 1 as before, and we'll just run this thing. And so it's complete, and so V0 is this. Okay, sure, not a big deal right now. Now we'll put this, so A0 would be the same thing as V0. So if I step now, line 3, but that's weird. I'm just gonna go to line 1 and so go. Let's run this. It's gonna take some time because it's running 2 loops and it's a simulator. Still, let's just have some patience. So what happened to the variables? It's some crazy big value. Why? I mean, it's supposed to be 1500 and then V1 is 15. What happened? Wait a second. No, but that's the thing. So A in A0, D in A1. So I put it as 15. Sure. Q in V0, R in V1. I did put A in A0. Not a big deal at all, right? What went on? Like, why did it not work the way it's supposed to work? It was working just fine before. 254 by 15, that was actually working. So why did it not? Let's try doing it with this instead. And we'll manually set the values. So instead of 254, what we'll set is not 15, so not this, but rather 1500. and once again go to line 1 and we'll run this. Let's hope things work out. Okay, what's your nothing? That doesn't make sense. It's 0? No, this is not making sense. Why? Why did it not work? It can't be 0. Now this is impossible. It was working just fine. Now it's not. Is 1500 too much for it or something? Add immediate 1500 is what? It's 1000, so it's more than 10 power. How many bits can you actually have in your these sorts of addresses? It's 32-bit numbers. 10 bits is it's 16 bits, right? Number of bits allowed is like 16, I suppose. Is it? But this is certainly I wonder. Something isn't quite making sense. Okay, so if I try it with some smaller number, it might just work, right? So let's just give 150 a try. And we'll start at line 1 once again. And we'll run this. And look at the stats. It's 10 and yeah, so it's as expected. So there it did not work out because the numbers are too big. Okay, that makes sense. So once again the same assembly code as before, but here we'll change the numbers. So when we were like cheating a bit and then storing as 100, where did we put that? Yeah. So instead of putting it as 100, we'll just put it as 10. Okay. I have no idea why this is going the way it is going, but well, that's just. So while we were doing the SW thing, we won't do it anymore. This as well. Add immediate. It's 10 now, just to debug. And yeah, so just to run this whole thing. Let's see the V value. So it's 10240. That once again is not quite correct. Doesn't make sense. It's the problem. So it's gonna be 100 over there. That thing is 15. Sure. What the? Why? Why did it not do it the way we want it to? How about if I just like put, I don't know, 1 everywhere, and if I start at line 1 and then I run this, what are the values? 2. Does that make sense actually? I mean that would be like 10, and 10 divided by 15 is certainly not that. So how did it? Oh, because it's 15 of these, so it's like 15 times of 1, so that's 15. But that still doesn't make sense why it would be 2. Nope, something isn't making sense. 2 of all things. It has to be 30 after this is done, right? Okay, let's try giving it just sort of a try. We know for sure it's just going to be still. So it's 15. This is 1 plus 1 plus 1, so on. That's 15. Okay. So if I do this thing and then run the other lines, and then this is 2. Why? This isn't making sense. How can it be 2? Still has to, and the remainder is 1. That doesn't really make sense. Increment it all the time. So 1 and 1 over there. What? Why? Why the hell? 32-bit number. 32-bit number, huh? So logical shifts in the end. Assigned number, isn't it? 31 shifts? No, it's supposed to be 32. That's just how it is. So you're saying me, so you're basically like telling me with 15 it won't work out. Okay. Interesting. So if I just do an add immediate, so forget all of this stuff. If I just do add immediate 0 and 15, so you're saying me it won't give me 1. Let's put it at line 1. Why did it go to line 2? Line 1. The hell? Hey, line 1. Okay, let's go to line 0. Let's see if it makes sense over there. What the hell? It's going to A0, 0, and 15. What are the variables? What the? Why isn't it able to actually? Why? This is frustrating. Some comment. Okay, step. No idea what happened. Just move on. And it's gonna run 30 times, but in any case, we just run this, and then we see the values. It is 1. It is 1. So why did it? Think about it. The thing that we input in there, it didn't somehow work, but why? Oh, okay. We're defining as loop. That's the problem. We shouldn't be. Let's call it loop 1. Here as well, let's call it loop 1. Oh, that was extremely messed up. Any other references that we are not doing correctly? I don't think so. So this is how it should be. Let's go to line 1. Okay, whatever. So just step. Let's see what happens. Why did you do that? You know what? This is gonna work. This is actually gonna work. Let's go to line 1. Step. Yes, it's working. So this is gonna run like 15 times, like so. Oh, I see. Oh, I'm really stupid. I have to do this. Okay. And then I just have to step, and okay, it's working the usual way. So if I run this now, then let's hope for the best. Okay. Ah, nice. Yes, this is what I wanted. It's finally working. It's not doing some garbage thing. And all of that just because of these two different loops. This is just stupid, but sure. Shouldn't there be some way to be doing these labelings like differently? I don't know. Anyway, so that works. Hey, so what was it doing? I was completing my assignment, obviously. So just Control C and just put that in there. And these are just for checking. Oh, sorry, not like this. It's these two. Okay, so this is done, I suppose. Yeah, my second question in the assignment is done. Okay, cool. So we don't need this. Let's go to the third one. The third question is write an assembly language program to find the LCM of two numbers stored at consecutive locations in memory. Are you kill me already. Oh wow, this is another thing which involves this div algorithm. Fine, I've written this for a purpose, isn't that right? So I'm just gonna do the thing. Okay, so A3 is the GCD algorithm. So once again we have to extract our whatever your stack pointer is. So we'll assume these are like in -4 and -8 and so on. Okay, then we'll load these words. So we'll say load word. So it's a GCD, right? So first what we'll kind of do is, let's keep A0, A1 free. Let's load these in A3, A4. Nah, let's load this in S0 and S1. We rarely use S0, S1 in any case, right? So just we don't do that. Sorry. Yeah. So right. So load word S0. In that -4 SP. So -4. That's 1 now. That's 8 SP. So let's call these as X and Y, and assume that like Y is less than X. Although there was no such restriction, but yeah, just assume that consecutive locations in memory. So they didn't say where, and so that's I'm just assuming it's in the stack pointer, like just above it. But yeah, so two numbers, right? Yes. So we just have to do the div algorithm once again. I don't want to be doing the stack call thing, but whatever. So we'll just copy this whole thing. So to reduce our whole problem with like compilation and all that, I'm just going to copy this whole thing, like not care. So this is our div algorithm. Okay, now what we want to do is the LCM algorithm. Wait, what? We want the LCM? Oof. So we know how to do the GCD, the lowest common multiple though. That's going to be a tough thing to do. So we'll have to do the multiplication algorithm as well. I am not looking forward to any of this. How do I multiply two numbers? Oh, just shift add. Sure. Think about it. Shift add, huh? 16 bits and 16 bits. The most a shift could be is like 16 bits in that case. Most we can do is just two 16-bit numbers. That's the thing. So we'll just do a GCD algorithm first, so that okay, cool. So what we first want to do is so if x is like bigger than y, so we do a set on less than on a t0. So first is like if y is equal to 0, so branch and equal if our y, which is s1, this is actually equal to 0, then we just say, well, end this whole thing, so call this final. And we'll just jump to final. Sure. Okay. Also over here, instead of using loop, let's use L just for the sake of it, because it's better that it's called L1, so loop 1 basically. Yeah, I'm just doing it so that it's convenient, like we can use some other variables everywhere else. This is going to be something like end div. Okay, sure. So if it's equal to 0, just branch out. It's fine, it's done. Okay. And all of this is supposed to be with positive numbers, but really you have to make it possible for negative numbers as well. But I'll just complete this for positive numbers first and then go to negative numbers. Yes. Now if sorry, my usual programming skills coming from. Okay, so branch and equal if okay, otherwise your y is some number, so we just take the quotient, right? So we have to put this in your a0 and a1, I suppose. So we'll just say add image or add your $s0, so $a0, the thing to be reduced and the thing which you will be reducing, right? So in a0 what we'll put is the bigger one, which is x, so just $s0, right? And then obviously 0. Okay, cool. Also we'll probably put a loop over here just for the sake of it. And this branch instruction we can put some, okay, never mind, this is okay. So add a0 s0 0. At the same time you also want to be doing this a1. For a1 we'll do s1, yeah, and this will like do the whole division algorithm for us. Then once this division is done, yeah, what then? At that point your v0 will be the divisor and this will be the remainder, right? Yes. So it's just the remainder that we really care about. So it's v1. So whatever is your a1, that will now be your a0, right? a0. s0 is more like it. Just make it s0. So add initiate. Oh, yeah, okay, a0. Or you could just say $s1. I mean, it's the same thing essentially. And then add immediate $s1. Instead of that, what we'll set is just the value that we got for v1, 0. So that way your remainder is siphon out, and at one point just becomes 0, so you put in 0 thing and then it branches out. Sure. So at this stage starting to wonder if this is making sense. Actually, no, you know what? Just put this in A0, that was in A1, and then in A1, put whatever was in B1. Sure. And before doing so loop only after you have done this thing, right? So given two arguments A0, A1, this function just does that stuff. Okay, so this is our GCD thing. It's a label. So we can go back to the loop. The loop is just the GCD. So wherever was your branch instruction, where did we put loop? We didn't. Right now we didn't. So this wouldn't be like final, but rather end GCD. Okay. So most likely we won't, end the thing. So in that case, we'll just jump back to GCD, right? Yeah. Once again, the same stuff. We'll check if it's 0. If it's 0, then we end. Otherwise, we don't end, and so on. We're assuming everything's positive and it's arranged in the correct order. I think this should actually work out. So let's just try it out. And for now, let's not use these load words. Yeah. And so what we'll do is instead add immediate $s0. Let's call it like, shit, it's not the correct thing. 0. And let's say 1 is like 8, 1 is like 4. So this is just to test. Okay, cool. Let's try it out. Line 1, the usual thing. I really hope something messed up doesn't happen. Why did it go to line 8? I don't know. Okay, somehow just always goes to that. Fine, whatever. So we'll step A0, so S0, that's 8. This thing is 4. And now this is 8, and this thing is 4. And now the GC algorithm starts. So if S1 is 0, it just, oh shit, this should be A1. This should be A1. So here as well, yeah, it's A0, A1 which we'll use. Okay. Damn, this is really just messed up, but whatever. So it's in the A1 value that you will have the not S0. At this stage, what has what value? V1 is 0, that means A1 is, so whatever was the last one. That was the question. So A0, right? Yes, that will have the value. Okay, so once you can just step. So he's trying to do the division thing. So it's going to be running like 32 times. I'll just wait and wait and wait and wait. How long? So how many times is 32 times? a lot. This should I just run this directly? It's not too late. I can still run it. Is it stuck or something? Oh, by one. Oh, oh, it's trying to do that. So, okay, should we add? Hope it actually works out. Okay, so the value is supposed to be at a0. In a0 the value is 4, which yes is the GCD. Let's try with something crazy. Let's try with 80 and I don't know, 20. I think we just run this thing. So what is the value? 20. Yes, okay, this is actually giving us the GCD. Sure. Now what we need to do is some sort of a multiplication algorithm. Yes. How do I multiply something? I have no idea. How do I actually multiply. Basically I just have to check the parity, right? Is that the case? Addition like that. I mean, it's okay. It's just log n times n. It's not a big deal, but still. Fine. So at least my GCD algorithm is working. That's one thing to be proud of. Next, what we want to do is just divide this whole thing by that. You know, this is inconvenient to be like pasting these division things everywhere, but whatever. At least we have the GCD thing working. Next, what we have to do is multiplication. Think about it. So you are given like two 16-bit numbers, want to multiply them. Easy task, right? Let's assume positive numbers for now. Let's not complicate things. So this will be like in a0, a1. Just like multiplication. So x in a0, y in a1. So y will be something like made up of a bunch of these numbers. So we'll have to keep some register which will keep shuffling, right? Yeah, so we'll make z equal to x initially. Then it will like, so our sum register is supposed to be somewhere, right? So let's say s. So s will be the multiplication basically. S in let's call that v1 or v0. V0 is more like it. What else? We also need to know where is, so it's the shifted x basically and shifted y. Come on, think about it. So we shift what? All three quantities, I suppose. Right. the first bit is 1, we put it there. Okay, and we'll shift it in any case. Damn it, this isn't making sense. It's gonna shift like that? Seriously? No, some parts of it are not making sense to me. That's supposed to be the 0th one. You don't just like reverse stuff. No, that doesn't work. You have to shift it like that. Come on. Think about it. Thinking. Oh, okay, I see. That's like 0 times of that, so we don't add it. Otherwise, if there is the thing, we add it. Then, so for the last shift, we still shift and add, and it's in the correct place value. So we never actually change your number to be added, as in, we never change our x value. So it will be s plus equal to x all the time. So if the first bit of y is 1, we add x to s. If it's not, let it be. And then we just shift the thing to get the next bit. Sure. And we keep shifting till the last bit is obtained. Yes. For the last bit, we add it, and then do we shift it? We don't. Right. So first we just do it for the first bit. Okay. Come on. So do we do the shift first and then the thing? Yes, I suppose. So we already store whatever is the thing. Okay, then we shift the thing. Sure. So the algorithm would go something like this. I'm just writing comments. So first, store the value of like is y less than 0. So basically like is is the first bit 1 or not? Okay. Then shift. So shift y. So basically y is shifted like by 1, right? So that like you can already have the next bit over there. So if y less than 0, so store in something in t. So if t, that is if the previous bit was there, if this was actually like 1, oh come on, in that case we just add this, right? Is that the thing? So whatever was the previous thing, we don't shift it right away, so we have to actually shift that first. So we'll do like s shifted by 1. We don't change anything with x. So if like so if t, if that bit was there, if it was 1, in that case we'll just do like s plus equal to x. Okay, and yeah, that's pretty much our algorithm. So for example, for a simple thing, if this is like a single 1 over there, we keep shifting, and when it's like 1, so just before, yeah, t1 is gone, it becomes like the most significant bit, so then y is 0. And I guess we add x to it, right? And it's also the 32th bit, right? So it's like this is the last iteration. Sure, we shift the y thing, we shift whatever s was, which was 0, and then t, so then we add x to it, and that works, that actually works out. Okay, this is cool, this is cool. So it's all just arithmetic shifts, I suppose. Yes, but for y it has to be logical. So for y we have to assume it's a positive number, right? So yeah, we will just assume both, so is positive. We just have to assume that one of these things we'll just have to assume, because otherwise it just becomes really complicated. So this happens like do 32 repetitions. So we'll have to set a counter variable. So we'll do add immediate $t2 0 and 32 bits. Okay, so some loop. Actually, we just call it like lm1 loop multiplication 1. Okay, then end multiplication. Sure, that's some label. We'll jump all the all the ways in any case. So if it's 0, scrap the whole thing. If it's not, keep going. So jump to lm1. Okay. So branch on equal to, if your t2 just somehow becomes equal to what, 0, in that case branch to end mul. Okay, before doing this we also have to decrement all the time. Sure. So add immediate. That's a for loop basically which I set up. Okay, now what we want to do is, inside this for loop we have to store s somewhere. So s is in v0. So first we just have to initialize that. So add immediate, or add, so $v0 to be just 0 and 0. Okay, then what we do is, so we added these two things, set it to 0. Now we have to keep adding x. Sure. So first thing, store this. So set on less than, so whatever we are setting, right? So let's call this as t0. It didn't actually put the dollar, that's bad, but whatever. Dollar, so y less than 0, right? So it's just dollar. Y was in a1. Okay, cool. Then y, we shift this by 2, so shift left, logical. It's in a1. Okay, then we shift s, so s is in v0. Which is in where v0 is just v0. Okay, then if t, so branch on not equal, so if t is like, if it's 1, do this thing. So if it's equal, skip the thing. So branch on equal, and then if it's equal to 0, so branch on equal $t0, yes, and 0. Will be like skip, so skip will be over here. Otherwise what we do is, so if we are not skipping, then we do s plus equal to x, right? So add, s is in what? S is in v0, and where is x? X is in a0. This is really I mean problematic, but sure. So we skip, add this immediate thing, sorry, what, yeah, so we skip, and we do 32 repetitions. Sure. Okay, this is fine. I think this is fine. So by the end of it, so we'll have this in v0. Okay. By the end, whatever is the value at a0, that times color a1 is in v0. Okay, let's run this. Let's see if this actually makes sense. Okay. So just for the sake of it, we are going to be setting a0 and a1 to be something, right? So we just say add immediate $a0 0 and something. So let's just say for now 2. Just something, like we don't really care what this is. And this one will be a1. That's also 2. So this is multiplication. Yeah, the usual. So it's at 10. So we step. Seriously, what am I even doing? Okay. So at least your T2 is decreasing, right? So I can just run this and hope for the best. Okay, so this should mean V. Yes, it's working. Sure, this is okay. So that multiplies stuff. So I'm just gonna copy this thing. And try to do the GCD thing, I mean the LCM thing, sorry. So this will be a3 dot s. Yeah. So far we have found the GCD, which is in a0, right? Next, we probably should just divide this thing, the GC. So we should divide the add immediate. Oh, so look, we are transferring your S0 S1 to these things, right? A0 A1. So we don't really have to worry about S0 S1 changing. So S0 S1 are still the same. So what I'm thinking is divide S0, right? So for your div thing, where did the div thing go? Right. This is your div algorithm. So once again, we are going to be doing some sort of a division. And yes, we should be making functions, we should be using the return arrays and everything, but right now I'm just too frustrated to be doing anything. Better? Sure, I hope so. If it's not, well, I don't care. So we're just dividing once again the same stuff, like, you know, your a0 a1 get divided, so a0 by a1, and that stuff goes to v1, right? So now what we want to do is set your a0 to be just S0. So by the way, we should actually store the GCD somewhere. So what we'll instead do is just say add $S2. So we didn't use that, right? So $V1, which is, so actually it's A0 which has the value S0, right? So this stores the value. Fine. Then add S0. So you've just moved your S0 thing to this. We want to divide it. So what? S2. So once this div thing is done, V0 holds the average, or I should say the holds the division. Okay. So now V0 just holds what? Like S0 by S1, whatever that value is. So we want this to be our new variable, so we call it S3. So just say add S3. Okay, sure. And then we want to multiply. So, right. So just set S3 is equal to S0 by GCD of S0 S1. Now we want to multiply this thing by S1, right? So once again, multiplication, what it does is like whatever is A0, A1, it does that. So add immediate or add. So in A0, what we want to put is your what this S3 thing. And in A1, what we'll put is S1, right? And it will multiply. So now this will be in V0, A0 and A1, multiplication of that. That will be like our S4. I'll just call that V0, we don't really care. So just put this whole thing. Let's see if there's any weird stuff happening. I don't think there's any weird stuff happening. These labels are like completely unique. You can't have a label being repeated anymore. Yeah. So let's just actually start putting this stuff in our simulator and run stuff. So the test that we are going for is 8 and 4. So this should now give us the what? LCM. Yes. So let's just go to line 1 and just run directly. And if it's correct, well, we'll get something. If it's not, we still get some weird thing. Okay, that took a lot of time. Oh wow, okay, it is correct. It really is correct, isn't it? Let's put 12. Let's see what stuff happens. And this should give us 12. If it doesn't, well, there's some weird thing happening. Okay, so what's your V0? Yes! One more question done. Okay, and yes, the science stuff is not there, but cut me some slack. I'm not an assembly level programmer. Like, I'm just a student trying to learn all this. So let's not talk about details for now. Uh, yeah. Next question. So 3 are done, 4 more to go. That's a long assignment. Write an assembly language program to calculate multiplication of two numbers without using mul. I did that. Wait, there's a mul command? I had no idea there's a mul command. Oh, so I'm already done with A4 pretty much. So our mul.s, that's basically like A4. So I guess ignorance really is bliss, isn't it? Sometimes you just have to take the hard path. And sometimes you just don't know that there's an easier path and you take it regardless. Okay, so assembly language program. So the given list of 10 numbers are sorted. If found, store 1 in input. This is binary search. Oh god, really? You want me to do binary search in assembly? What? Find a given number in list of 10 numbers. So if this number is found, store it. Okay. The given numbers have been loaded from X location memory. The output has to be stored at the next location. And if found, store the number of iterations and the index of the. So basically, a binary search. Yeah, I guess this is it for this video. I don't have the guts to be doing a binary search just like out of the blue. And also these questions. So the next one's like write an assembly program for character in string thing, which is okay. I mean, that's just a linear search thing, so not a big deal, I suppose. Right? Just put a single for loop and see if it's gonna work. Because character is just like what? It's more numbers pretty much. Might be inefficient, but whatever. Next we have these things. Assembly line program for calculating a factorial. Oh god. Oh god. Yes. That's actually not so bad. You just have to do a for loop and then a while loop and then just multiply stuff. And you already have a function to multiply things now. So not so bad, but really want me to program now, don't you? What's the use of a compiler if you are just going to make me program? But sure, I guess. Write an assembly language program to find the GCD of two numbers stored at consecutive locations. We did that. We just did that. We did these things. So you are saying there were commands and I didn't ever search it up and I just went and wrote a whole division algorithm just for the sake of it. I'm kind of cool, am I not? Okay, write an assembly language program to bubble sort. We are doing binary search, so bubble sort won't be that hard. We'll get used to it when we do that. Find a substring. Okay. Seriously, why are you now you're putting DSing in this stuff? A substring in a string. Just crazy. This is crazy at this point. How do we usually find a substring? The KMP algorithm. Oh, never mind. I'm not going to optimize this, and not in assembly at least. I'm just going to write the most basic bullshit program that anybody has ever seen. Like order n square. I don't care. Yeah. Alright then, so I'll see you guys in the next video. Bye.